As a designer, you've always required the most powerful and most expensive workstations on the market. But with more of the workforce working remotely than ever before, you need a more flexible environment. With a 3D Experience platform, you can design on the cloud with any device without sacrificing the performance and power required for you to stay productive no matter where you are. Dan and Don have been tasked with wrapping up a design of a circular saw. Dan's an industrial designer in charge of the ergonomics and aesthetics. Don's a mechanical engineer who will prepare the models for manufacturing. Let's drop in on Dan as he shapes a grip handle with 3D Sculptor. With subdivisional modeling, you basically start with a digital hunk of clay that automatically maintains curvature continuity across all faces. But this design requires flat faces at both ends of the grip handle. So he'll get a head start by creasing the outside edges while placing the initial cylindrical shape. With 3D Sculptor, Dan can freely push and pull the model into any shape imaginable, but most of the time, designs are required to fit within a specific boundary. By activating the bounding box, he can input a series of overall dimensions and the shape snaps precisely to size. Dragging the arrowheads of the on-screen manipulator allows groups of vertices, edges, faces, or the entire shape to be translated with no rebuilds required. This allows you to see the changes as they're happening, so you can hone in on the perfect adjustments. The dots on the manipulator can also be dragged to scale the geometry. Dan would like to propose various concepts of this grip, but he wants to be able to come back to his current design if his ideas don't pan out. By creating a new feature set for each of his concepts, he can simply copy and paste features from one set into another. Now he can edit the duplicated sub-D feature, get started on his first concept of the grip, and rest assured the original start shape will remain intact. Some more tweaks from a few more angles, and this first concept is just about complete. Finally, to collect feedback from the rest of his team, Dan can post the entire 3D model to an internal community. Opening the 3D model and adding markups on any device streamlines the communication process, allowing teams to arrive at that perfect design faster than ever. With the ability to create subdivisional models directly in a browser on any device, complex shapes have never been easier to create.
After starting the design in 3D Sculptor to create the ergonomic grip handle, it's now been turned over to Don, the mechanical engineer, to complete the design and prepare for manufacturing with 3D Creator. Don will need to create the stem connecting the body of the circular saw to the grip handle. To start, Don can create a mounting flange with little effort. By pre-selecting the face and context of the assembly, he can skip the sketch and extrude his first feature. Sketched ellipses include construction lines, making them easy to orient. For example, Don can snap the quadrants of the ellipse to the midpoints of the external model edges, or he can also click on both the point and edge, opting to create the same relationship in the pop-up menu. While extruding the feature, a preview is displayed, making it easy to confirm the correct end condition has been applied. But on second thought, Don is underwhelmed with the resulting shape and would prefer a sleeker look. To accomplish this, he can roll the design back before the extrude feature to create a curved path. Starting with a 2-point spline, he can activate the spline handles to achieve full control over the curvature. Relationships can be applied to both ends of the spline, and the handles can be adjusted until it looks just right. Don rolls the model forward to edit the original extrude feature. Not only can an extrude feature be changed to an extrude cut, it can even be transformed into a revolve, or in this case, a sweep. It's called a super feature, and it provides an unprecedented level of flexibility as all references are maintained. Since this part will be injection molded, it's important to specify a parting line. By activating the parting line option on the draft analysis tool, Don can pinpoint its exact location. After adding a few more features, Don has split the body into 2 halves. To make these bodies easier to work with, they can be divided into separate sets of features. This way, each set of features will be independent from each other. By hiding the other feature sets, Don can focus on the lower half of this design. To lighten the design and prepare for molding, Don adds a 2mm shell feature. To reinforce the hollow design, he can sketch a profile for a rib. Even without perfectly trimming the sketch entities, The rib feature will project the geometry to fill the internal volume of the component. If necessary, draft could be added at the neutral plane or where it intersects the inside walls of the part. Design changes are nothing to be afraid of in 3D Creator. And with the visual insight provided within modes like draft analysis, Don can rest assured this part is ready to be sent to manufacturing. Having the right tools allows you to get to market faster and reduce costs. For example, the milled angle bracket and base plate of this circular saw are not only expensive to manufacture, but also require additional assembly steps. Don recognizes this, so he decides to use 3D Sheet Metal Creator to consolidate these two components into one. On the 3D Experience platform, all applications are compatible with each other. With a seamless switch from Xdesign to X Sheet Metal, the toolbars in Don's user interface update so he can stay focused on the task at hand. Don will start by isolating the components he plans to replace and creating the new replacement component. Copying the footprint from the original base will give Don a head start on the redesign. These holes are no longer necessary, so they can be removed. X Sheet Metal includes advanced context recognition, which means he'll have quick access to the tools he wants, keeping his mouse cursor focused on the model. While getting started, he's conveniently prompted to provide some overall sheet metal parameters to be used as default values, saving time on downstream features. Don hides the original base plate, as he's captured all he needs for this first feature. To enhance the design, he can bend this front edge upward, so the base can smoothly glide over workpieces. The position of the bend is precisely defined by a sketched line and can be set to any angle. Not all sheet metal features require sketch. In this case, Don selects the outer edges of the base to add some short walls. There are multiple alignment options to perfectly position the added material, such as measurement criteria and material side. To confirm the corners were trimmed per the default parameters, the current design can be flattened at any time. The new cost-effective design requires a flange that mimics the angle bracket. Using the intelligent context-sensitive menu, Don creates a rough clearance cut for it. Once again, he converts the profile from the previous design and makes some small adjustments. To strengthen the connection to the base plate, he'll remove these entities and close the gap by merging the endpoints. Even though this sketch was created out of plane, it can still be used to create a wall and edge feature. The default tangent relief set earlier may not apply here, but Don can override it on the fly for this unique instance. Finally, you'll want to adjust the material side to ensure the flange doesn't interfere with other components. To account for manufacturability, Don can check for overlapping geometry in the flat pattern. With an overlap detected, he can measure the highlighted edges to assess how big of an adjustment he needs to make. By subtracting the necessary clearance directly within the dimension field, X Sheet Metal does the math and reduces the risk of entering the wrong value. Sharp edges could be dangerous to the end user and increase difficulty to cut, so Don uses the corner tool to gather the edges and round them off. Another way Don can improve the design is by adding a guide rail. This will require a pair of clearance cuts through the sidewalls. Don starts with a rectangular sketch offset from the end face of the guide rail. By deselecting the link to thickness option on the cutout tool, the cut can extend through the entire model. Of course, all cut faces will be created normal to each surface to allow for a conventional laser or water jet cutting process. A slot needs to be created to hold the guide rail in place. In manufacturing, a feature like this would be stamped with a forming tool, and it can be modeled using the exact same technique. First, he'll have to find the tool using the 3D Experience platform's powerful search capabilities. Then, he can define its location on the model with the sketch point. Finally, the user stamp feature allows him to specify the direction, fillet parameters, and which faces to remove from the resulting geometry. To give this new sheet metal component a realistic look, Don searches the extensive material database for a galvanized metal appearance and applies it to the part. These materials are perfect for making design reviews more engaging and also support downstream workflows such as product renderings. Don will supply his design to the cutting machine using the industry standard DXF format. This will include the cutting profile, bend lines, and user stamps. Saving it to his 3D drive allows him to share the file with anyone so they can view it and add markups using the 3D Play app. Additionally, these markups can be shared to a community to notify a key project stakeholder and discuss further changes. Before closing his browser for the day, Don notices another component that will require a flat pattern before it can be manufactured. Unfortunately, this component was created using traditional modeling features like extrudes and cuts. Still, Don's able to get the information he needs to use the Recognize tool to calculate an accurate flat pattern.
Now it's time to finalize the materials, colors, and aesthetics to produce some high-quality marketing content and complete this project. Let's see how this can be accomplished with our brand new cloud rendering capabilities of the 3D Experience platform. When creating a new rendering project, Dan has access to all of the current design data via the 3D Experience platform. And it's apparent a handful of components in the circular saw already have appearances that were applied during the design phase. This gives Dan a head start as he prepares to make some adjustments. Creating a new scene lets Dan tweak the appearances while preserving the materials and colors the designers originally specified. Dan will change the color of the housing from red to blue, and set the blade guard to a light gray. At any point, Dan can enable the rendering preview to check in on his progress. This is a perfect way to verify materials and color selections are just right before moving on to the final render. Simple camera settings can also be modified on the fly. Dan decides that a 35mm wide-angle lens looks best, and he'll switch to a 16:9 aspect ratio for a more modern look. Now it's time to render the project. Simple output options lets Dan adjust his images to a standard HD resolution and a high-quality setting. With a click of the mouse, the 3D Experience platform takes over by rendering this image right on the cloud. Dan returns to the red variation to work on another rendering even while the blue rendering is still being processed. This time, an interactive turntable will be used to extend a virtual walk-around to the rest of his team. The job is submitted and run side by side with his earlier request. 3D Render allows endless rendering processes to be done in parallel, never slowing down Dan from tackling his next task. After only a few minutes, each rendering is complete and are ready to be shared. Dan has the option to download these locally, save to the 3D Experience platform, or directly post to the team's collaborative 3D Swim community, where everyone can view, comment, and finalize their decision. Now that the color has been decided on, Dan's ready to add a higher level of realism to his renderings. 3D Render supports a wide variety of advanced materials. For example, Dan searches for a used saw blade appearance with scuffs and scratches. Once found, he can drag and drop directly from the search results to apply it. A glimpse at the preview window and Dan gets instant feedback of his material selection. Other 3D design assets can be repurposed and added into a 3D render project as well. Searching the team's design library shows a woodworking table. Dan drags this in and positions the table to the saw for a perfect composition. Applying an ambience to the background adds a nice final touch. Just a few tweaks to the background size, the exposure, and the camera perspective sets up the perfect shot. Dan is once again ready to send another project to the cloud. Using 4K resolution with the ultra high quality rendering option, this image will be approved for publication in no time. Whether you're creating quick renderings for internal design reviews or generating professional level marketing assets, 3D Render on the 3D Experience platform provides an easy, affordable, and scalable option for all users on any device. So whether you're doing industrial design, mechanical design, sheet metal fabrication, marketing quality renderings, or all of the above, now you can do it all on the cloud on any device. To learn more about any of these apps, please check out this website and contact your local reseller.